Greetings and welcome, friends. Mr. Wadi and Mis Amigos de Algebra are here, and we're taking a look at writing equations of lines that are best fitting of a scatter plot. But before we get there, let's take a look at some of these examples. It says, use the scatter plot to fill in the missing coordinate of the ordered pair. Let's see, for problem 3, Ethan, could you help me out with problem 3? 16 has what for a y coordinate? Let's see if I go over to 16. That's this point right here. Its corresponding y coordinate is 6. Thank you very much. Cameron, the point 3 comma what is on this graph? Let's see. So here's 3. Oh dear. Oh, wait a minute. 2, 4. Wait a minute. This is 4. So 3 must have been halfway between there. So Cameron, what do you think the y coordinate is for the data? It looks like 14. That's a sad squiggly line there. But 314, I like it. All right. Amity. Opposite question. What point has a y coordinate of 12? Ethan, thank you for following along, please. Devin, you as well. So 7 is the corresponding x coordinate to that. So this is a point that had an output of 12. And Adriana, what point had 17 as its y coordinate? Let's see if I trace across to this one from 17 and bring it around town. Looks like ocho is the value there. Very well done. Thank you, friends. So notice that these points do not exist on a line, but you might kind of describe them as being line-like. All right, here, how about this? It turns out that the hard drive capacity, as that increases, tends to increase with the price of a laptop. So it says, this shows the case for 10 different laptops. It says, what is the price of a laptop with a hard drive capacity of 8 gigabytes? All right, there we go. So here's 8 gigabytes, and if I trace this across, what do you guys think that... It looks like about $1,100. I don't know where I was going there. 11 hundo. Bam. And then it asks the question, what is the hard drive capacity of the $1,200 laptop? So that's the opposite type of question. If I take 12 and go over, it looks like, yeah, no bottle flipping, thank you. That is 12 GBs, 12 gigabytes. And then what if I asked you the question, as hard drive capacity increases, what tends to happen to the price? Guys, you can be quiet. You're not even talking about math. If I draw an ellipse around the data and I connect the endpoints of that ellipse, it kind of can draw a best fit line. But it seems as though, what was your thought, Amity? What were you saying? Yeah, that the price tends to increase, right? That this line would be going up, and because it has a positive slope, you could say that there's a positive correlation that as hard drive capacity increases, then the price increases. Perfect, perfect. And you might even be able to make a prediction. We're really going farther on this problem than we need to. What if I was like, how much should a 10 gigabyte laptop cost? Right? If I used this to predict a point... Yeah, but that's okay. But my data... Gentlemen, you can be quiet, thank you. Would be around $1,100, right? And I do want to point out, you're right, it was the same as the actual 8, but my predicted 8 might have actually been more around 900. So my line doesn't perfectly match reality, but it kind of is like an average. It's a way of talking about what tends to be happening here. All right, here's question 13. It says, make a scatter plot of the data and tell whether or not it shows a positive, negative, or no correlation. So I had provided you guys with this data on a spreadsheet, right? You could access it. Bam, there's 199, question 13. If you select your data like so and go to Insert Chart, Spreadsheets had a variety of options, some suggested recommendations, but if we go to chart types and scroll down, gorgeous. There I can make a nice little scatter plot. Now, looking at that, what do you think the relationship is between this data? Yeah, it doesn't really seem to have a great correlation going on there. Also, I have got a Desmos graph that'll show you the same thing. And, yeah, it does, I don't think so. Oh, okay. Yeah, it's almost like a constellation going on here. Now, today we'll do a little bit of this, mx1 plus b. Oh. Now, my computer can give me a line of best fit, but it's not good. It is not good. And we're going to talk about how can I know how good my line of best fit is. That's one of the things we'll talk about today. Foreshadowing. So I'm going to say no correlation. Right, no correlation. There's really not anything going on between that data that I could make predictions with. All right, let's keep going. Here we go. Now we're getting to the real problems. Question 15. The table shows the world birth rates Y per 1,000 people since the year 1960. So what does 0 represent? And what year is that? 1960. What does 10 represent? 1970. Here, Devin, you can close your laptop. So that's what those represent. And then these numbers, 33.6, does that mean there's like 33.6 children born in that year? That's the number of births per 1,000 people. And that's an average. That doesn't mean there was 0.6 of a kid that was born that year. So let's take a look at the data. So if I go over to, what was it, question 15 here. You could, I'm going to use the Desmos graph. I love my Desmos. But you could have made a chart if you wanted. But let's take a look at the Desmos like this. And I'm going to screenshot like this. Oh dear, I can't see it. Oh wait, oh, it's on my other screen. That's funny sauce. Funny. And it's asking me to write an equation that models the birth rate. So let's see if we can do this together. All right, so first of all, I'm going to try to draw a line that represents that data. Pull out the line tool. And when I do so, I want to point out, first I should try to match roughly the slope of that line. And then roughly the points where I'd have, on average, Devin, I think I asked you to close your laptop. On average, I should have about the same number of points above as there are below. Another thing I'll point out is that it doesn't necessarily hit any of the points. Okay, it doesn't necessarily pass through any of those points. I don't know, something like that maybe? So let's draw this. This is my line. I don't know. And we could all have different lines. So our slopes and y-intercepts are all going to be a little bit different here. So I'm not going to use one of these points when I try to write my equation. I've got to locate some points on my line. Does anyone see any points that happen to be kind of on my line or that I could use as an estimate? I'm thinking, I'm liking this one. What do you call the first one? Oh, this one? I think that's a direct hit, yeah. And so in this case, it kind of looked like it picked, I could pick one of the points that was part of my data, but I might not necessarily have any of my data actually on the line. So let's find these coordinates. So if this is 20, this is 10, what are the coordinates of this point? This looks like 15, comma, what? Let's see, if this is 50, 10, 20, 30, 40, 50. So 15, comma, 30? Okay, and what are the coordinates of this point, friends? Looks like, yeah, 50, comma, 20. Yep. All right, so using those points, let's now find our slope and our y-intercept. Okay, so the slope, that's going to equal y2 minus y1 over x2 minus x1. And let's simplify this and solve. So 20 minus 30 is negative 10. 50 minus 15, 35. Both of those are divisible by 5. Right? So I'm going to have m is equal to negative 2/7 is my slope. All right, how do I find the y-intercept? Now, I could try to guess it off of the graph, but let's get the exact y-intercept of the line that passes through those points. I'm going to plug this in for x1 and y1. I could use either slope-intercept form or point-slope form. What do you guys prefer? Let's do point-slope today. What are your thoughts, Ethan? Yep. Oh, you're looking at that? Now, that is where this purple point exists, but my line doesn't actually pass through that point. Well, I don't want to guesstimate. I want the exact y-intercept of this line that happens to pass through these orange points. We'll find out. Let's see. There we go. So let's plug in what we got. So y minus 30 equals negative 2/7 parentheses x minus 15. So y minus 30 is equal to negative 2/7 x. Let's distribute here. So you guys should be writing this down if you don't have this correct. Negative 2/7 times negative 15. I know that's positive, and it's not going to cancel out great. That's going to be positive 30/7. Ugh. We can start working with decimals, by the way, because this problem has decimals in it. 30/7, 30 divided by 7, is going to be, I've got 4.29. And now what do I do to solve for y? Add 30 to both sides. Okay, here we go. So I got 34.29. There's my equation. Oh dear. Oh, my writing tablet died. No. All right, it's back. There we are. So let's actually write this equation into Desmos and see what we get. So I've got, oh yeah, it is low batteries. That's okay. All right, so I'm going to hit enter, and I'm going to write an equation. So I'm going to say y equals negative 2/7. Let's get out of that denominator, x, and what was it? Plus 34.29. And I can see that that is my line, and notice that it wasn't passing through the same point there, and actually it might not have hit. Yeah, it actually didn't hit. Oh, other than that one point that we ended up picking, it didn't hit any of them. But now I can use this to interpret the slope. So what does the slope of this mean? What does negative 2/7 mean in terms of this problem? Well, the y value was number of births. Yeah, so the number of births per 1,000 people is going down 2 for every 7 years. All right. So let's see, was this part B? So negative 2/7 is negative 2 births per 1,000. All right, stop doing that, gentlemen. Per 7 years. Okay, that's what that's talking about. And what does the y-intercept mean? What does my 34.29 mean in this problem? No, it's not. There it is. What does my 34.29 mean? That means in year 0, which was what year? Guys? Amity, you paying attention? All right. What year is year 0, friends? The year 0 is 1960. That means in 1960, there were about 34.29 births per thousand. All right, so that's what that y-intercept means. That was our starting point. And then we'd be able to use this to make all sorts of predictions where I could be like, okay, so in 50 years since 1960 was 2010. What year would our year be on this graph? If 2010 is 50 years after 1960, then I would be looking for 17, right? Actually, let's just write that. Let's write the equation x equals 17. Why is that a capital X? There we go. X equals 17. There we are. Wait a minute. That's not right. Oh, no. 67. My bad. No, 57. I'm wrong again. That's okay. Mr. Wada makes mistakes. All right, there we are. 57 years after 1960 is the year we are in now. And we would expect that this year there's about 18 births per 1,000 people. Okay? What does the trend suggest? What is this line doing? What appears to be happening here, guys? It's going down, right? Now, does this, based on our model, this is saying that 120 years after 1960, so that would be the year, what's that? Oh dear. What's that, 20? I know, exactly. 100 years would be 2060 plus 20 more, so 2080. That means that people won't be having babies anymore in the year 2080. That's weird. Not necessarily accurate, okay? Not necessarily accurate. So there's our model, and we can make all sorts of cool predictions with that. Let's keep going. I think I've got one more for us. 24. This is what the one that Pooja was asking about. Make a scatter plot of the data in the tables. Describe the relationship. Is it possible to fit a line to the data? So here we go. Here's 24. Let's look at my graph. And come on, Mr. Wada, gotta make a click. All right. Does that look like a line represents that very well? No. No, let's actually even find the best fit line. So if I say y1, check this out. y1 is about mx1 plus b. It can give me a line that represents it, but it's a terrible job, right? It's not doing great at all. It turns out later on in our course, we'll look at a different type of equation. What if I did ax1 squared plus bx1 plus c? Look at that. Now that's actually like a pretty good representation of those points. Now it's a weird curve, and we'll look at those later, but the point is that not all data follows linear trends. So this is not represented well by a line because it changes direction like completely, and it's actually better represented by a curve. All right, thanks for watching, Internet friends. Adios.